You are listening to the Information Security and OSINT podcast, episode 11, originally released on June 12th, 2020. My name is Josh Amishav. This week we're going to talk about command line hacking, or how we can use Bash and Vim as part of our recon process. The issue that often comes up is that tools don't do exactly what we need. We want to automate certain tasks at scale. We need the flexibility to grab the output from one tool, massage it, and then feed it to the next. So we're going to talk about how we can use Bash and Vim to create custom tools today. Direct support for this podcast comes from BreachSense, the data breach monitoring platform. What's the easiest way hackers break into your network? By using valid usernames and passwords. Attackers collect millions of leaked credentials from almost daily data breaches. Without visibility into which of your employees or users' credentials have been leaked, it's tough to protect against this. Integrate BreachSense's powerful yet easy to use API into your existing security solutions to prevent account takeover and stop online fraud. Let's start with a quick Bash tutorial. Some of this will be quite obvious to a lot of listeners, but hang in there, there's also a bunch of really cool shortcuts that you may not be familiar with as well. Bash is a shell that wraps around the kernel that lets you launch processes. Linux has three standard I/O streams. Standard input, known as descriptor 0, which by default is the keyboard. Standard output, also known as file descriptor 1, which by default is the screen, and standard error, which is known as file descriptor 2, and that's also sent to the screen, but it's separate from standard output, which comes in useful when we want to only capture certain parts of the data, the output. One of the nice things about the shell is that you can redirect the standard streams using the less than and greater than symbols. You can also use ampersand greater than file to redirect both the standard output and the standard error to a file. This comes in very handy when we want to grab things like curl output, meaning the HTML response headers for later parsing. Well, we can run something like ls greater than output.txt to redirect the output of a command to a file. We can also grab the output of a command and use that as input as well. For example, we can compare the output of two different commands by running something like diff less than and then in parentheses ls, and then a space, and then another less than, and in parentheses ls space /temp. Right? That would compare the output of the current working directory and the files within /temp. We can also capture the output of a command via backticks or the $ parentheses syntax. And actually, the $ parentheses syntax is preferred for a number of reasons, like readability, and especially how it handles nested quotes. An example would be files equals $ and then parentheses ls. That would capture the output of the ls command and insert that into a variable called files. Now in Bash, I should note that you set a variable using just its name, but when you call the variable, you append a $ to the variable name. And using our previous example, if we want to access the value of the files variable, we'd use $files. Now, this is the InfoSec and OSINT podcast, so let's talk about how we can use Bash and Vim as part of our recon methodology to create custom tools. One of the previous topics we discussed is subdomain enumeration. Say we have a list of subdomains like admin.example.com and dev.example.com, www.example.com, etc. We can use the host command to check if the domains resolve. When we run host example.com, we get back example.com as address 93.184.216.34. Alternatively, when we run host against ineverexisted.com, we get back host ineverexisted.com, not found, and then a 3NX domain. Well, this is pretty easy for us to know which of these domains are valid. If we're going to do this at scale, we need to do this programmatically. Now, we could grep the output for the string has address, or even better, we can look at the command exit codes. So every command, when you run it, it returns an exit code after it completes. And we can access the exit code via the $? For example, if we run host example.com and then echo $? We get back a 0. If we run host ineverexisted.com and then run echo $? We get back a 1. But we should really only look for anything that's not 0. So let me give you an example to explain why. Say we run ls I don't exist, and then echo $? That's going to return a 2. So it's always best to look for either exit code 0 or anything that's not exit code 0 to be able to differentiate between the command exiting with a positive response or failing for whatever reason. Now, the next building block is to start using conditionals. These are things like if statements or while loops. Now, this lets you decide to perform an action by evaluating a specific expression, like if command works, then run command. And then if in Bash you predicate, if it's an if statement, you predicate it, you start it with if, and then you end it with fi, which is if backwards. So for simple things, we can just run our conditional like if statement on the command line, like if host example.com, then echo domain exists fi, which prints domain exists to the screen. If we run host ineverexisted.com, then echo domain exists fi, then nothing is printed to the screen. Now we're going to start combining some techniques we discussed earlier. One of the problems with running the host command is that we get too much information back. For example, when we run hostexample.com, we get back the IPv4 address, as well as the IPv6 address, as well as the MX records. Now, if we're doing recon on a target and only want to know if the domain resolves or not, then we can send all that output, the standard output and the standard error, to dev null, which is like a big void, by redirecting the output of the host command with ampersand greater than /dev/null. This way, we only get back the string domain exists. Another useful tool is the while loop. We can say while command works, do run command, and then you finish it with done. So for our subdomain enumeration, we can combine this with the read command to read in a line from a file provided to the script and assign that line to a variable, and then run the host command against that variable. While the while loop is provided with a list of domains, it will cycle through each, and the read command assigns the domain to a variable that we set, and then we run host against the variable to see if it resolves. Once the command gets too complicated and messy, it's usually a good idea to put it in a file so that we can add in line breaks and comments to improve readability. I'm a huge Vim fan for this. It's extremely versatile and has a lot of shortcuts that help you save time developing and debugging the code. The first thing when creating a bash script is that we need to add a shebang to the top of the file to tell the kernel which interpreter should be used. Now the first line should start off with $, then exclamation mark, and then the path to the bash executable. Now, for me, that is in /bin/bash, but yours may be somewhere else. So one shortcut is to hit escape, and then the exclamation mark twice, then type which bash. This inserts the output of whatever command you ran, in this case, the which bash command, into the file. Once the script is written, we need to give it executable permission. So to do that, we don't actually have to leave Vim. We can run escape : and then exclamation mark, shmod, and then +x for executable permission. Of course, if you haven't saved the file, you'll need to do that first. If you need to jump out of Vim, you can just run :sh to go back to the shell, do what you need to do, and then Control-D to go back into Vim. Now, humans are really good at finding outliers visually. We can use Vim for this as well. Let's use Yahoo as an example because they have a pretty broad bug bounty scope. Let's say we enumerate a bunch of Yahoo domains, ran them through HTTP probe, figured out which ones are web apps, then we use curl to grab each of those web routes and store them to our file system. At this point, there are probably several thousand files we need to inspect. Now, let's say we want to look at the title of each of the pages to figure out which ones might be interesting to look at for a bounty. We could run rg or grep across the files, and then we can pipe that into vim -hyphen. This grabs the output of our grep command and stores it inside the Vim buffer for us to view. One note I want to add: when running grep for the titles, you'll probably want to use the -E flag to enable extended regular expression support, the -I flag to make the search case insensitive, so that way if you've got title uppercase or lowercase, it'll grab both, and the -O flag, which just returns the matching part of the line. This helps cut out a lot of the noise. At this point, it'll become obvious which titles aren't interesting. So when finding anomalies, it's usually easy to figure out what we don't want, remove that, and then figure out what remains if what remains is relevant, and then we just rinse and repeat. We can do that via the %! command. So for example, we can do %! grep -v yahoo. The -v flag inverts the search, so any title with the string Yahoo in it gets removed. And we keep on whittling down until we find potentially interesting targets. If you need more granularity, I suggest using awk print command and setting the field delimiter with the -f flag. Now, one last thing I want to touch upon is while Bash is really easy to develop scripts in, it's not always appropriate for all scenarios. It's a tool in your tool belt, but it's always a good idea to use the right tool for the right job, which may be Go or Python or whatever. Now, one of the biggest complaints with Bash is that it's slow. We can, however, speed things up sometimes. We can use the parallel command or xargs to execute commands in parallel, which greatly speeds things up. Now, xargs comes with a -p, which is a capital P flag, which lets you control how many processes to run at the same time. Just an example, I created a list of 250 potential Yahoo subdomains, and I wrote a simple script that just runs host against them. So say the script is called resolver.sh. I ran cat subdomains, which was my list of subdomains, and then I piped that through xargs -n1 capital P10 and then /resolver.sh. Now, xargs by default accepts multiple lines of input, so we need to use the -n1 to tell it just take one line at a time. And then the -p, we tell it to run 10 processes simultaneously. Now, this command took 540 milliseconds, so about a half a second to run. And I ran the same command and changed the -p to 1, and then it took 2.860 milliseconds, or almost 3 seconds to run. So obviously this is a silly example, but when you have thousands of domains to resolve or running a process that does take time, using xargs -p can be extremely helpful. To summarize, Bash and Vim are great tools to help automate the tasks that we run often. Bash scripting is very easy to learn as you're basically just running a bunch of command line tools in succession. And Vim isn't just a text editor. We can use it as part of our recon methodology to help find outliers, as well as a buffer to massage text in order to be able to make sense of it. That's it for today. If you have any questions or feedback, please contact me at podcast@breachsense.io. That's podcast@breachsense.io. And if you got value from this episode, then please share it with a friend. See y'all next week.